C. And then I say here, you have a circle here. Who's subtending A then?
BC.
It's BC, né? Sure. So if
Yes.
BC is the one who's subtending there, let's look at the following then. I'm saying here we have an angle between a tangent and a chord. Okay, that one is fine. So we have an angle between a tangent and a chord. This angle here is an angle between a tangent and a chord. But what I'm asking is this. Is there any angle subtended by this chord DC?
No.
There's no angle. Okay, let's check that here. If I go from B1,
There's
look at B1.
B1.
Can you see B1 again? Huh?
Yes.
Now, if I go from B1 and then I extend this line, where do I end?
D.
At C. né? And then if I go from here,
Yes.
where do I end?
Go D.
Go D. So who's subtending B1 then?
DC.
DC. né? Yeah, so we have an angle between a tangent and a chord DC. There's an angle between a tangent and a chord DC. Then it means, in other words, B1 and D1, I'm going to highlight them with the same color. These two are going to be equal because it's the tan chord theorem. An angle between a tangent and a chord is going to be equaling to the angle subtended by the same chord in the alternating segment. So B1 and D1 are going to be equal because of tan chord. So I'll write that here and say I have tan chord theorem. Now, after that, we can then also check the following. Look at this. There's an angle between a tangent and chord BD. Can you see that one?
Yes.
Is there any angle subtended by BD in the alternating segment?
C.
Angle C. Okay, angle C is subtended by BD, but this angle and this angle, they are in the same segment, so they are in the same side. They can't be equal. This one and this one, they can't be equal because they're in the same segment. Is there any other angle subtended by BD?
A.
Angle A, né?
And O1.
Angle A and O1, yeah. So we are going to say that angle, this one, D1 plus D2, as you can see, I made them to be red. né? D1 and D2.
Yes.
D1 and D2 are going to be equaling to A, not O, because O is at the center. So the angle between a tangent and a chord is equaling to the angle subtended by the same chord in the alternating segment at the circumference. So it can be at the center because we know which an angle at center is 2 times the angle at the circumference. So remember that. I think that we're given that if we continue after the tangent, we are given that BC is equal to DC. Now, BC and DC are chords again. BC and DC are chords. Then we can then say, look at the following. We can say then this here, this angle and this angle are going to be equal. Let's just check. Why am I saying that? Why are these two angles equal? This one and this one.
They're angles opposite equal side.
So they can be angles opposite equal side, or they can be angle equal chord subtend equal angles again. But because this is a triangle, then we say this one is angles opposite equal sides. Okay, now let's go and start to work then. We've highlighted all the information that is given from there, and then now we can start to work. They say they want B2. Now let's check B2. Here is B2. We can all see B2. No? Now B2 and D3. Can you see them again?
Yes.
B2 and D3 are equal. Why are these two angles going to be equal? Let's say we have B2, which is going to be equaling to D3. This is equaling to D3, is equaling to 10. Why am I saying that, by the way?
Because they are angles opposite the radius.
Yeah, so we have angles opposite equal sides. Now remember, this is a radius, this is also a radius, so it means which these two are going to be equal. If they are equal, then we have angles opposite equal sides. Then those two are also going to be equal. So we'll come and put here, we have 10. So if this one is 10, it means this one here is also going to be 10 degrees. We're still good, guys?
Yes.
Okay, let's move on then. We go to O1. Any suggestion how would we get to O1? We want to get this angle here.
Because like O1, D3, D2, like they form a triangle.
So they form a triangle. Okay, so we are
Yes.
going to say O1. So we'll say O1. O1 plus D3 plus B2. They're going to give us 180 degrees. And then you say in triangle. So we're looking at triangle DOB. And then we're saying this is going to be sum of angles in a triangle. And then if we say that, then we're going to say that we have O1, which is going to be equaling to 180 degrees minus, we know what is D1 and B2. This is 20. So it means our O1 is going to be equaling to 160. Then we'll come and put it, okay, now we have this one here. This is 160 here. Jane, how would you get A if it's you?
Angle at center is twice angle at the circumference.
So you will say that angle 160, which is O1. O1 is going to be equaling to twice A. And then the reason that we are going to say why this, we're going to say because we have an angle at center, which is going to be equaling to 2 times angle at circumference. And then after that, what are we going to get as A? We have 160 again, which is going to be 2 multiplied by A. We divide by 2, we divide by 2. It says A is going to be equaling to 80 degrees. So we'll come and put here, which now we have 8 here. So this one here, it's 80. So far, so good, guys. Are we still together? Show by the raise of hands if you are still with us. Just raise your hand if you are still with us. Okay, Khomutso is still with us. We are moving on. We want to get angle C. We want to get angle C. Okay, angle C. Khomutso, how would you get angle C if it's you? Let me show you angle C. This is where angle C is. How would you get this angle here?
Yeah, Mr.
Yes.
No, like the opposite, like the former 108
plus 80. They're going to give us 180 degrees. And then you're saying your reason here, you want to say it's opposite angles of a cyclic chord.
quad. Yeah.
Okay. And then it says angle C is going to be equaling to 180 degrees minus 100. And then it says C is going to be equaling to 100. Okay. So we are moving, guys. We are moving. We're almost there. We are almost there. We are just left with 2 now. We are just left with 2. So we'll come and put here with this one here. It's 100 here. Just raise your hand, guys, if you are finding it difficult, whatever it is that we are talking about. Just raise your hand. We'll stop and then assist you. Okay, we are moving on then. We want B1 now.
Yeah,
Jane.
Mr. 2 times. Whoa.
Do you still remember that, Jane?
So, Mr.
Yes, Khomutso?
So, like, our Mr. Lanchira got crying on us.
Can you see now?
B. I get one, the credit more Mr.
Okay, let me, like this. Can you see now?
Yeah, Mr.
Okay.
B1, lead D2
Yeah.
that look at.
Yeah.
Okay, re ke scenario. Re ka se re ke di like ke x if re ke x if re x plus x if re plus 100 degrees is equals to 180. If it's a sum of angles in a triangle, if it's a 2x is equal to 80 degrees, if it's a x is equals to 40. Because it become homes.
Yeah, that's what we're going to do. That's what we're going to do, Humutu. So we'll say we have E, number E. On number E, we'll start by saying D1 is equaling to D2. And then you say we can call them X. According to you, say let's call them X. And then we'll say this is because we have opposite angles opposite equal sides. So here we have angles opposite equal sides. So here we'll say we have angles opposite equal sides. Okay, now from here, based on what you said we make this one to be X and then we make this one to be X. Then we can say X plus X plus 100. They're going to give us 180 degrees. And then you are saying the reason here is going to be sum of angles in a triangle. Then what then follows from here, Humuto, is that we are going to do exactly what you said. We're going to add X and X. If we add X and X, what do we get? We get 2X again. And then if you take this 100 to this other side, we are going to have 180 degrees minus 100. And then we have 2X, which is going to be equaling to 80. Divide by 2, you divide by 2. It says X is going to be equaling to what? 40 degrees. Then it means we can come and say, okay, yeah, this here is going to be 40. We can now come and update our diagram and say we have 40. So this is 40. We put 40 here. And then we also put 40 here. Okay, from here onwards, guys, let's look at the following. We are looking for the last one. We are almost there. We're almost there. We're almost there. We are looking for D1. D1. Remember, when we started, we had something like this. I had this. I said, you think I was using a paper cut. I said this angle here. Still remember?
Yes, Mr.
Yes. Okay. How would we get P1 then? How would we get P1?
Why is it going up, Mr.?
Yeah.
Kare ka mokgwa mo mpotsa ka teng nako tse tlo nzumela tsona Mr. Wa re ho thoma mo D3 mo la ho fitlhela ko D1 di forma 90 degrees. So ka re 30 degree le teng.
You want us to use the following, which if we go from here up until here, this is going to give us 90 degrees. Ne?
Yes, Mr.
Okay, let's use that. Let's use that. So we'll say we have D1 plus D2 plus D3, they're going to give us 90 degrees. So that is going to be our number F. So on number F, we'll say that F, we have a D1 plus D2 plus D3 is going to be equaling to 90 degrees. And then the reason that we are going to use here, it's tan perpendicular to radius. And then from here onwards, you can say then D1 is going to be equaling to 90 degrees minus. So it's 10 plus 40. Ne? What is 10 plus 40? Yeah?
50.
Yeah, it's 50. Then it means our D1 is going to be equaling to what? 40 degrees.
40 degrees.
Does anyone who